Good morning. Last time we looked at how to determine the ground state term for a d9 atomic orbital. Today I want us to look at how to determine the ground state term for a d10 atomic orbital. As usual, we write down the angular orbital quantum number, which is represented by L, which is 2 for a d orbital. Then the magnetic quantum number. Magnetic quantum number begins from plus L, 0, and negative L. So since the L is 2, we begin from plus 2, plus 1, 0, negative 1, and negative 2. Then the spin quantum number. Each electron can spin upwards, represented by plus half, or downwards, represented by negative half. Then we write down the orbital. A d orbital is a 5 degenerate orbital. Then we write down the magnetic quantum number of each orbital. Then we fill the orbitals with electrons. We have 10 electrons. So we obey the rules in filling orbitals with electrons. So first we fill with single electrons in the same spin. Then after that, we pair up. Now we have 5 electrons remaining. So we pair up in opposite spin. The next thing is to determine the total orbital angular momentum, represented by ml. The total orbital angular momentum is the sum of the magnetic quantum number of the electrons in the various orbitals. So considering the first orbital, the magnetic quantum number is 2. But taking into consideration the 2 electrons, we have 4. And the next one, we have 2, because we have 2 electrons here. Here we have 0. Here 2 electrons, we have negative 1, so negative 2. 2 electrons, we have negative 2, so negative 4. So we have 6 here. 6 minus 2, we have 4. 4 minus 4, we have 0. Then we determine the total spin angular momentum, represented by ms. To determine the total spin angular momentum, we sum up the spin quantum number of each electron in the orbitals. So considering this electron, it is spinning upwards. So the spin quantum number is plus half. This is spinning downwards, negative half. So plus half minus half is 0. So we can ignore this. We ignore this. So we ignore this because they all give us 0 answer as a spin quantum number if we add the plus half and the negative half. Therefore, the ms, the total spin angular momentum, is 0. Then we determine the spin multiplicity using 2s plus 1, where the s represents the total spin angular momentum, which is 0. So we replace the s with 0. So 2 times 0, 0 plus 1, we have 1. From the previous video, we know that if we have the total orbital angular momentum to be 0, the term is an S term. Then the spin multiplicity, we have 1. So we have 1 here. So the ground state term for a d10 atomic orbital is 1s. Thank you very much. Please subscribe to this channel, share and like to motivate me to produce more videos like this. Thank you.